Okay. All right, everybody, let's get started. I hope everybody had a good break. We're on lecture 20, and we are done with AutoCAD. I'm going to say I enjoy AutoCAD. I do, but I'm ready to move on to something else, and this is a good time to do it. I'll say this about Inventor. We're going to fly through Inventor. We're going to go pretty fast, but the thing about Inventor is I will say two things about Inventor. It is different, but I think that most students agree it's easier, okay? There is a little bit of a different way of operation that you got to get used to. Once you get past that, you'd be surprised how quick you'll be able to pick up Inventor. The students that learn AutoCAD first, a lot of the skills that they learn with AutoCAD, when they translate them to Inventor, suddenly they find Inventor really easy to use. Just a heads up, we're still working on getting everything graded. One of my TAs was sick and whatnot over break. But our goal is to have everything checked off this week. I don't have a homework assignment today because we're going to have a homework assignment on Wednesday, due Monday, same pattern as before. This first homework assignment in Inventor will probably be a lot more guided than the AutoCAD assignments were over the past few weeks, but then past that it'll be a little bit more on you. The only other thing I'll mention, for those of you that are using Macs and are accessing Inventor through Cameo, again, the link is cameo.marshall.edu. The one thing that might be a little tricky is saving, and what'll happen is if you save a file, it might be hard to find out what drive to save it to, but if you go to the X drive and go to the MS folder, that is your OneDrive. Okay, so you can save Inventor files to your OneDrive account in that directory. So those of you that have Macs, again, if you go to the X drive, you go to the MS folder, that'll be your OneDrive. And for those of you using Cameo through Windows, it's the same process. Okay, has everybody scanned the code? Has everybody scanned the code? Okay. All right. So I want to say a few things about Inventor, and because again, I think it's easier. I do. I think that there's a couple things you got to get used to, but it is a lot easier. Okay. One of the things about Inventor is that it is more meant for 3D than it is for 2D. Okay. But you can do some really wild stuff with it. Okay. You can do some really impressive projects with Inventor. We're not going to do anything this elaborate with Inventor, but it is definitely possible to do something this elaborate in Inventor. Okay, so I want to say a few things about Inventor. Inventor, the way I would separate it from AutoCAD is AutoCAD, I would say that the CAD stands for computer-aided drafting, whereas in Inventor, I would say it's computer-aided design. Okay, Inventor is really sort of meant more for the design phase. See, in AutoCAD, you're sort of preparing drawings for an object that's already been figured out. Like, to give you an example, if I asked you to draw a rectangle in AutoCAD, you all would ask me, okay, how long is it? How wide is it? Where does it go? You know what I mean? Because the idea behind AutoCAD is that you're preparing drawings for something that's already been figured out. Whereas in Inventor, the idea is that you're figuring it out as you go. Okay? So there are some slight differences to how it operates. Now, in addition to being just a basic geometry creation, style program, it can do a lot more. For example, it can do some stress analysis, which we'll do near the end of the semester. I have an idea for a really fun homework where we'll look at stresses and we'll look at, for a given problem, what material you should use for that project. I think you'll think that's kind of nifty. But the other thing I'll mention is that while it is a little different, it's not terribly different. Like, it is an Autodesk product, so there's a lot of common features. Like, we're still going to be creating 2D sketches in Inventor, and we're going to be doing it using a lot of the same commands that we use in AutoCAD. So, like, a lot of the stuff that I would take my time with in Inventor if we did it first, we're going to kind of fly through it because we've already done this stuff. So, again, I think you'll think it's pretty slick. When you first open Inventor and you start to create a new file, there are oodles of different options, but to try and cut through the noise a little bit, I'll say that Inventor really has sort of two main types of files. We have parts and we have assemblies. And really the difference is that an assembly is just a bunch of parts, okay? And so like the idea behind it is that assemblies have value when you have parts maybe that repeat, or if you want to edit parts one at a time. It's like, for example, if you're designing a machine and you have the same screw that's used over and over again, you just create a single screw and you just repeat it over and over again in that assembly, okay? So an example of an assembly, which probably by the time we're done, you'll be able to do something like this by the time we're done with this semester. As you can see down below, we can see an assembly here of a bunch of parts. And so we're going to spend most of our time in here learning how to generate parts, because if you can generate parts, an assembly is just a bunch of parts. Okay, so it's really not that much more difficult. This is what Inventor looks like when you open it. I'm going to say this. It has some slight differences with AutoCAD, but when I first showed you AutoCAD, I was going on and on about here's what the ribbon looks like, here's what this toolbar looks like. I'm not really going to do that in Inventor because it's an Autodesk product, so it has a lot of the same flavor and a lot of the same feel as AutoCAD. So we're just going to sort of learn as we go. Probably the biggest thing that you have to get used to is that there's no command line in Inventor. It's not like AutoCAD where you're executing commands. Like you are executing commands, but there's no command line, as it were. Okay, so we're going to go through a quick tutorial today on how to use Inventor. Okay, and what we're going to do is generate that. Okay, we're going to do this and we're going to do it together. We're going to generate a 3D part. Okay, this tutorial, I would say, is probably one of the most important tutorials in Inventor. If you can do this, you're good. Okay, what we're going to be doing for the rest of the semester past this is sort of extensions of this and learning how to modify this, put some fillets, put some chamfers on it, assign material to it. But really, if you understand how to do this, you're going to understand how to navigate about 80 to 90% of any 3D modeling challenge that you need to do. While we're using Inventor, there are other 3D packages like Solid Edge and Pro-E and all that, and a lot of their operation is very similar. So a lot of the ideas and skills that we're going to learn with this are going to translate to just about any 3D modeling package that you would use. Okay? Now, we're going to be modeling in 3D. Regardless of what program that you're using, regardless of what approach that you're using, and regardless of what part you're trying to create, there are several schools of thought behind how you should build things up in 3 dimensions. And we're going to use a little bit of both today, but I sort of have a simple way of putting it. The first is what I would call the carpenter's approach. And so what I mean by the carpenter's approach is take an object, build it, and then cut away, like remove material from it to go from point A to point B. Okay, that's what I mean by the carpenter's approach. Like start with an object and cut material away from it. Remove geometry from it in order to generate this. So I might start with a block and end with this link of, or this chain of 5 links. Okay. Whereas the other approach might be something like the Play-Doh approach. Okay. How many of you have ever used one of these before? Seen this? You have a bunch of Play-Doh and you have an extruder, right? So you take the Play-Doh, you stick it in the extruder, you hit the little button, and what it does is it takes this 2D cross-section of maybe like a heart or a star or something like that, and it extrudes it into a 3-dimensional object, okay? We're going to use both today. And so the analogy for the part in question is that we're going to create a 2D sketch, extrude it into 3 dimensions, and then remove material away from it or add material to it in order to generate the part in question. Now, the example that we're going through today is really guided because I'm trying to introduce you to Inventor. But what I'll tell you is that if I just give you a part and say, create it, you're not really going to be told sometimes, well, this is how you should create it. You as the engineer need to think about what's the most efficient way of taking this object and generating it in 3 dimensions. Okay? So just want you to think about this as we begin. Okay? Any questions? All right. Now, the single most difficult thing I would say that takes some getting used to in Inventor is dimensioning. Okay? This is the one thing that I would say is really different between AutoCAD and Inventor. And if you can get used to this, you're going to be fine. Okay? So let me sort of explain. So how does this work in AutoCAD? In AutoCAD, if I say the example before, draw a rectangle, I say, okay, open up AutoCAD and draw a rectangle. Some of you will just draw an arbitrary rectangle, but some of you are going to say, okay, wait a minute. You said rectangle. How long is that rectangle? How wide is that rectangle? Where do you want it, right? In order for us to all arrive at the same answer, you need to know the dimensions before you create that rectangle in AutoCAD, right? But you have to know the dimensions. That's not the case in Inventor, okay? Inventor doesn't work that way. Because Inventor, the idea is that you create a geometry, and then as you're going through the design phase, you might want to tweak that geometry. You might want to change it a little bit. You might want to change the thickness or change the length of those legs of that angle. So the idea in Inventor is that what we'll do, so if you look here at the screen, I have here this L shape, okay? So on top, I just have a rough L shape that I just drew, right? No dimensions, no specificity. Other than that, it is an L-shaped cross-section. So I just drew that out. And then after I drew it, I then go back and assign dimensions, okay? That is really the big difference between AutoCAD and Inventor, at least from a first-time use standpoint, is the idea that you can create the shape and then assign dimensions later, okay? If you can get used to that, you're gonna be good to go, okay? So in order to do this, I just want to dive right in. So we're just going to dive right in right now, okay? So I have here Inventor open, okay? I have a bunch of files that I've been working on and whatnot over break, but I'm going to pass this around, and we're going to go through this example today. So okay, so I have here Inventor open. As this handout's coming around, okay, so I'm going to hit New, and you get a template file that opens. I'm going to make this a little bigger so y'all can kind of see what's going on here on the screen. Okay, so I have here a series of templates that I can define, and I want to be clear, at least for the purposes of this class, we're not going to get too fancy on like create injection moldings or things like that. We're not worried about that. You mechanicals might learn that if you take Dr. Salary for manufacturing processes. He might show you a little bit on that. But for us, we're just trying to get through the basics. So we're going to create standard parts, at least for the vast majority of the rest of our time together. And like I said, if you understand how to create a part, then an assembly is just a bunch of parts. So we're going to create a standard part. So we'll click standard part here in inches. We'll hit create. You should be able to create in metric as well if you would like. We're just going to do English units for now. And then here's our interface, okay? Excuse me. Now what I'm going to do is right off the bat, I'm going to go to File, Save As, and I'm just going to put this here on the desktop. We'll call it Lecture 20. Okay. Now, let me move all this. I was working on some research and whatnot over break. I'll move all this over here. Okay. Now, one of the things I'll mention is that as you go through the process of creating this file, you will see, so I have Lecture 20, and then you'll see another folder pop up called Old Versions. Inventor will store old versions of the file that you're working on as you create it. Okay, so you'll see that in your directory as you work. Okay, with me so far? Okay, all right. So what we're going to do is we're going to begin by creating a small component of the geometry that we're working on. And really, the main purpose of this is just sort of get used to Inventor, okay? Now, the first thing that we're going to do is create the most basic 3D geometry, which is an extrusion. And so an extrusion is really like the Play-Doh problem, right? Create a 2D sketch and then just extrude it. So like, for example, if I wanted to create a cylinder, just draw a circle and extend it up. That's basically the idea, okay? So what we're going to do is we're going to start off by creating a 2D sketch, okay? So if you look here on the top left, there should be a button here called 2D sketch. And then when you do that, you get a view that probably looks something like this. Is everybody seeing this? So we're creating a two-dimensional sketch, and so what Inventor is asking us is, okay, what plane do you want to draw that on? And if you hover your mouse over these planes, you should see like the XY plane, you should see the YZ plane, the ZX plane. We're going to do the XY plane. That's this one right here. So we're going to click this. And now we're into sketch mode. Okay, so we're drafting in 2 dimensions. Okay, now look at the top. What do we see here? We see lines, circles, arcs, rectangles. I've seen all that stuff before, right? So this is the part where I said, we're going to fly through this because I don't need to take a step back and go, here's how to draw a line. You all know how to draw lines. We've been doing this all semester, right? So we can go through this part pretty quickly, okay? Now, here's what I want to do, okay? So what I want to do is I want to draw this L-shaped outline, okay? But here's the thing, okay? I just want to draw it. I'm not worried about dimensions right now. I'm not worried about position. Just draw the thing, okay? So I want to show you how we're going to do that, okay? Now, I'm going to start off by executing the line command. So we'll just click the line button. And I'm just going to start drawing lines. Now, I want to be clear, as you draw these lines, okay, remember in AutoCAD how as you're drawing, it would sort of snap to drawing lines up and down and left and right, like orthographically? Inventor will do the same thing, okay? We're going to let it do that, okay? So let me just sort of draw a line. So watch this. See how it sort of snaps a little bit? See how it snaps? And you can tell it's snapping because next to the cursor, you'll see a little symbol pop up, and that symbol sort of indicates that vertical constraint. You can see that right here. And what I'm going to do is just draw an outline, okay? I'm not going to worry about dimensions. I'm not going to worry about the specifics. I'm just going to try and get it rough. Now for this one right here, make sure that when you draw it, that it snaps to where it's sort of aligned with that point right there. Click, click. I'm going to give everybody a second. Oh, let me get that. Move away from there. I want to move away from there, but I want to give everybody a second, see if you all are able to do this. And again, I'm not worried about where it is. I'm not really worried about its specific size and just getting it close. And I know that some of you are still going through the installation process. That looks good. Looks good. That looks good. Oh, you have it. Yeah. Did everybody get a handout? You have an extra one? What? Whoops, okay. Okay. Is everybody got this sort of figured out so far? Okay. Anybody have any questions on generating the L shape? Okay. Now, here's the thing. The thing about Inventor is that it really wouldn't be very useful, though, if we couldn't apply specific dimensional constraints. Like, I want this angle, I'm going to call it an angle, this L shape, I'm going to call it an angle. This really wouldn't be very valuable if I couldn't apply specific constraints to its dimension. Like a rough angle doesn't help me as an engineer. I need to know specifically what that is. Well, the way that we handle that in Inventor is we apply what are called constraints. Okay? Now, some of these have actually already been applied natively throughout the construction of this sketch. For example, does everybody see these little symbols right here at the vertices? Everybody see these? What do you think those mean? What do you think those mean? They're perpendicular. Essentially what it's saying is that those angles are 90 degrees. Okay? So it has constrained that geometry such that those are 90 degrees. Now I'm not done. I need to apply some more constraints. Now, the most common constraint that we can apply is a dimensional constraint. Okay? And a dimensional constraint is basically dimensioning a line or dimensioning an object and saying, I want it to be such and such a dimension. Like for example, watch this. Okay? So I'm going to go here up top. You can see the constrain menu. I'm going to hit dimension. And notice how, all this went away. I'm going to click this. I'm just going to click the line and see how I've got this dimension thing pop up. Now mine says 2.157. Okay? So if I click, let's say down here, I can put what I want. I'm going to put 2.5. Enter. And by golly gosh gee, look what it did. It changed the geometry based on the constraint I applied. Let's do it again. Let's do another one. Okay? Specifically what I'm going to do is I'm going to make these two outer legs 2.5. And I'm going to make the thicknesses 3/4. So let's do it again. Let's do another line right here. Let's do 2.5. Let's do this one right here. That one was pretty close. And so now I have applied dimensional constraints to this sketch. Okay? Now, I mean, I'm not married to those values. I could go in if I want. See that where that says 0.75 up top? Maybe I don't like that. Now, I don't like 0.75. I can just double click it and make it 0.25. Boom. You can just change it at will. Okay? Again, this is probably the thing that probably takes the most getting used to with using Inventors. AutoCAD doesn't work that way. Like once you draw it, the object's there. There's a little bit more permanence to the objects that you draw in AutoCAD, and it does require a little bit more from you as the user up front. Okay. All right. All right. I want to take a step back and see how everybody's doing with this. Yes. Might have deleted some lines. Okay. We'll look at this later. Good. We'll look at it later. Everybody with me so far? Okay. How about over here? Everybody good? Any questions? Okay. All right. Now what I'm going to do is, so what I've done so far is I've created a two-dimensional sketch. But again, that's not really where the value of Inventor comes in. The value is in 3 dimensions. So what I'm going to do is I'm going to finish this sketch. Okay. And now what it's done is it's brought the sketch sort of into 3D. Okay. But what do I do with it? I'm going to Play-Doh it. Okay, I'm going to Play-Doh it by creating an extrusion. And what do? I just hit the extrude button. Now, Inventor's really smart in terms of trying to figure out what you're doing. In other words, like Inventor knew that I only have one sketch that's active, so I'm just going to extrude that sketch. Okay. And how much am I going to extrude it? Well, I can extrude it as much as I want. I'm going to extrude it for this problem by 2.5 inches, but I do want to mention a couple of things. There are a couple options that you have as the user. So for example, if I make this 2.5, okay, so I've changed the dimension, and you can see that now, you know, for example, it was 1. Now if I change it to 2.5, you can see, you know, it extended further. I have a couple of options that I have in terms of the direction. For example, this is the default direction. I could extrude the other way. I could extrude symmetrically, okay? So it extrudes in both directions. And if I really want to get fancy, I can sort of extrude at an angle, and we might even look at extruding along a path later. But for now, you know, I think this is good for at least beginning, okay? Now we're going to hit OK. And by golly gosh gee, we've got our first part created in 3D. Okay. By the way, I should mention that your mouse in Inventor works pretty much the same way as it does in AutoCAD. Like if you scroll the wheel, it zooms. If you double click the wheel, it zooms to the extent. You can click and hold and pan around. All that stuff works, okay? So just worth mentioning. Okay. Now, the other thing I do want to mention is this is 3D, okay? So I do want to make sure that you all understand how to rotate things in 3 dimensions, okay? So, y'all good? Okay. All right, so a couple things I want to point out are what's going on here on the right side of the screen, okay? So the 2 things I want to point out on the right side of the screen are this cube and the little toolbar down below. Now this cube, first off, you can click and drag this cube. So like if you click and drag it, you can actually rotate the object in 3D. But really where its value is that if you literally click the cube along a given edge or a corner or a face, it'll rotate to that. For example, watch what happens when I click front. There's the front view. I can click up here. There's the top view. Let's go back to the front view. There's the right view. Anytime you click home, it brings it back to isometric, okay? If you want, you can click an edge and it will view it along that edge, or you can click a corner. Let's click that corner. Boom. Boom. And again, you can always click home and bring it back to its original view, okay? So the cube up top is sort of your global orientation, but you can easily go to a specific desired view. The other thing that I'll mention is the little navigation wheel, okay? Now, down here on this little toolbar here on the right, there's a bunch of options. What I want to click is this top one, this full navigation wheel, okay? Now, this is what the navigation wheel looks like. You can always close it by just hitting the top right corner, but you got a lot of power here in terms of affecting your view. Now, the way that it works is that you basically click and hold one of these buttons, and then moving the mouse will respond accordingly. Like, for example, if I click the zoom button, so I'm going to click the zoom button, and I'm going to hold it, and if I move my mouse up and down, it zooms. If I click the pan button, click and hold, it pans. If I click the orbit button, it orbits. You see what I mean? And when I'm done, I can just close it, okay? So you ought to mess around with that a little bit just to make sure you're comfortable with it. But when you're done, click the home button so we bring it back to looking like this. Okay. So far, so good. How's everybody doing? Everybody good? Okay. Now let's have some fun. Let's start building this geometry up. Okay. Now, here's what the geometry is supposed to look like when it's all said and done. this right here. Okay? So what I have here on the screen is not enough. Okay? I need to add some stuff to it. Okay? So what I'm going to do is I'm going to add a feature. Okay? And I'm going to combine a feature using the join operation. Now, the way that I'm going to do this is pretty much the exact same way I built this original object to begin with one slight little tweak. Okay? Now, what I'm going to do is I'm going to do another sketch and another extrusion. So I'm going to create a 2D sketch. Okay? Now, when I create a 2D sketch, something different happened. Remember before I had those 3 planes that popped up? That didn't happen here because now I have an object to reference. Okay? So instead, what I'm going to do is I'm going to click this top surface right here. This is going to be my reference surface. So I'm going to draw right here. Okay? So I'm going to draw a sketch with that plane sort of acting as my sheet of paper. Okay? Now, what I'm going to do is I'm going to draw another angle. Okay? I'm going to draw another angle, and I'm going to draw another angle in this bottom left corner here of the screen. Okay, so I'm going to do that again. So let's draw this down here. And let's draw it like this. Okay. Let's draw another little angle like that. Okay? Now, what I'm going to do is I'm going to dimension this, but I'm going to dimension it a little differently. Okay? I'm going to provide the 4 dimensions that I originally did, but I'm actually not going to change them initially. I'm just going to place a dimension right here, but I'm just going to accept it. Place a dimension here, accept it. And I'm just hitting enter to accept it or clicking the little check mark. Okay. Now, in order to create those dimensions, I clicked the line, and Inventor was smart enough to know you want to know the length of that line. I am also going to create 2 more dimensions. I'm going to create 2 more dimensions that define the distance between this point and the edge of the part. Okay? So just to point it out over here, I'm going to create 2 more dimensions between this point and the edge of the part. Now the way that you do that is when you click the dimension, see how it hovers over the line? You need to click the point. Click the point and then click the line. We'll just hit enter. Click the point, click the line, and we'll stick that, I don't know, over here. Okay? So I've got these 6 dimensions right there. Okay? Now the first thing I'm going to do is I'm going to do this in order that I have here on the screen, or on the sheet. So I'm going to double click these dimensions, or just single click, sorry, single click. 2.5, okay. 2.5, okay. Then we'll do the thickness, 0.75, okay. 0.75, okay. But now what I'm going to do is I've got 2 more dimensions. I've got these dimensions here between that corner and the edge of the part. And what I'm going to do is I'm going to make those dimensions 0, okay? Now, does everybody see what that's going to do? If I make those dimensions 0? It's going to take that angle and stick it over on the edge. See, watch this. This is 0.638, make it 0. Boom. Take this 0.583, make it 0. Boom. And so essentially what I did is I sort of attached that sketch to that edge. Now there are other ways of doing that in Inventor. Like you could use a coincident point constraint. We'll talk about that stuff later. Right now I'm just trying to get you familiar with the idea. Okay? But when it's all said and done, I'm going to hit finish. It should look something like this. This is what it should look like. Okay? So I'm going to take a second, make sure everybody's comfortable with this. How are we doing? How are we doing? I think you went off the wrong plane. What? There we go. Yeah, you need to redo your sketch because it's on the wrong plane. You need to click that. Don't forget the dimensions, the 0 dimensions. All right, how's everybody doing? How's everybody doing? We got time. I want to make sure we're good on this. How y'all doing over here? Yeah.
Oh my.
Yes, you need a dimension.
That's it. Yeah, that's it.
Does that make sense?
What are we cutting? I got the shape. Where's the back here? Where's the back? There's Control Z. Yep.
How y'all doing over here? How y'all doing over here?
Join option.
So, what you need to do is you get a file, save as, this is what I'm saying. You go to this drive.
I think that's the join option. There's a cut join. Yeah. Cut option is what we'll use next. Remove geometry from given.
Okay, so we did it right.
You don't have OneDrive installed or not?
Yeah, it's
How's everybody doing up
Now
here?
we'll cut out the hole.
yeah to see it's joined together.
How's everybody doing up here? Everybody good over there?
Bring it in.
How's everybody doing over here?
Good.
We're chilling.
Sketch.
There we go.
That's okay. You're good. How are you doing?
Now we're gonna start.
Are you doing
2D sketch right there.
Okay.
Circle.
How are y'all doing?
Where's the center of it? Where we get the center of it?
From the top.
Oh wait, we just make a circle. And then we dimension.
Okay. All right, eyes up here. Eyes up here. I want to show you something. Okay. So we're going to do the same thing. We're going to do another extrusion. Okay. So I'm going to hit extrude, but there's a couple things that we got to focus on. Okay. So first off, when I click the extrusion button, I want everybody eyes up here. Watch this. Watch this. So when you click the extrusion button, okay, first off, Inventor knows to extrude that sketch because we just created it. But notice how it's extruding upwards. Okay, it's extruding upwards because it's basically going along the positive direction of this axis down here. That's basically the way that it's following. I don't want it to extrude upwards. I want it to extrude downwards. Okay, so I'm going to click this little button here next to behavior where it says direction and see how it extrudes downward. Okay, but you might not notice this, but there's a couple of additional options down here under output. Okay, and specifically there's this menu called Boolean. Okay, now Boolean is basically the logic that Inventor is using to create join geometry. The default option is to join geometry. So in other words, that's the first button that's picked right there. So what that means is that if I have extrusion A and extrusion B and I join them, it will become a single part, okay? That's what the join option means. There's a couple of other ones like cut and intersect. We aren't going to use intersect today, but we are going to use cut, okay? But I'm going to hit OK. And now I have a single extrusion, a single part. That single part is made of two separate extrusions, okay? Everybody with me so far? Now, are we done with this part? No. We've got a couple things we need to do. This is what it's supposed to look like at the end. What am I missing? I'm missing a hole, and I'm missing this little notch here in the corner, okay? So let's start off with the hole, okay? Now what I'm going to do is I'm going to create an extrusion right here, okay? Now I just want to forewarn you before we go any further, and I'm sure that there's a few of you that have a little bit of experience in Inventor. I'm sure some of you are saying, well wait, Dr. Mike, why don't you just use the hole command? That's true, yes, there is a hole command that we can use to create holes, but we're taking it one step at a time, and this process will allow us to create cuts of a generic geometry besides just a circular hole. And we'll look at holes and other geometry modifications later. So right now what I'm going to do is I'm going to create another 2D sketch, and I'm going to create it on this plane, okay? This plane right here, okay? Because what I'm going to try and do is I'm going to put this little hole in there, okay? So how do I do that? Well, I'm going to create a cylinder, okay? I'm going to draw a circle right here, and I'm going to place it a certain distance away from the edges. So let's first off draw a circle. Now the way I'm going to do this circle is I'm just going to put the circle right there, but instead of just, I'm actually going to type in the diameter this time. You can do that if you want for any of the dimensions. I know that this is going to be 3/4. Let's just do that. Boom. I got a 3/4 inch diameter circle right there. Then I'm going to place two dimensions. One dimension from the center to the edge. We'll make that 1.25. And one dimension from the center to this edge, 0.75. So it's not quite in the middle. It's a little bit off. Okay, just a little bit off.
I like this.
All right. So we're going to hit finish. And then we're going to do another extrusion. Okay. Now, let's take a look at what it's doing. It's by default extruding upwards. It's by default extruding along the positive y-axis. Okay? Now what I'm going to do is I'm going to flip it. But I want y'all to notice the color of the cylinder. Watch this. Watch what happens when I flip it. You see how the cylinder changed color? See, like here it's green, now it's red. Y'all see that? Okay? But I also want you to notice the Boolean option. Look what happened here. Look how the Boolean went from join to this. Interesting. What happened there? Okay? What happened there is Inventor is really smart. Okay? And Inventor knows that if you have a solid and you're extruding an object through that solid, you're probably doing a cut. Okay? I want to cut that material away. So a join command will take the two objects and join them, whereas the cut command will remove that material anytime that it intersects. Okay? So I'm going to make that extrusion 0.75. It could be more than 0.75. It wouldn't really matter. Then we're going to hit OK. And look at that. Now we have a hole through the part. How's everybody doing with that? Does that make sense? Everybody good? So the only thing left to do is this little notch here on this corner, okay? And the way that we're going to do this notch is we're going to do yet another extrusion. We're going to start a sketch on this plane. Okay. Now this angular little notch here on the end is a little clip out of that corner. Okay. Now what we're going to do is we're going to draw a triangle right here, and we're going to dimension it accordingly. Okay. Now I want to say, because you're drawing along an edge, you might need to start the line over again, but you can. It'll be pretty straightforward. So we're going to draw here to here, and again, like the line command kind of stops. You kind of need to start it over again. So there, to there, to there. So again, as long as you have a triangle right there, because it is that triangle that we're going to extrude. And how are we going to dimension this? We're going to dimension it such that this line, dimension it. So this is actually a good point. So if I try and select this, it's trying to select the edge. What I'm going to do is dimension from point to point. Activate the dimension command. Point to point. We'll make that 1. And then we also need to dimension the angle. Okay, this is a 45-degree angle. So what I'm going to do is dimension this edge. So click this edge, but instead of placing the dimension, I'm going to click this edge. Now look at the cursor. Watch what happens when I move it there. See how the little symbol pops up for an angular dimension? So we'll click that, and by golly gosh gee, you can see the angular dimension, 45. You like my little by golly gosh gees? You like that? That's a technical term. Okay. How we doing? Doing good? All right. I'm going to finish this extrusion. Or finish this sketch, finish this sketch. And then I'm going to do an extrusion. Now again, I want it to go the other way. Now let me show you something. All right, so I'm making the extrusion 0.75. Watch what happens if I make it 2. So if I make it 2, you can see that it's going like that, right? What happens if I make it like 3? Okay, see what happens if I make it 3. See how it's going through that plane and even into the next one, right? I don't want that to happen. So as long as I make it less enough that it only goes through the first plate here, then I'm good. So we'll make it 0.75. Then hit OK. And boom. Done. If you understand the basics and the concepts about how to do this, you can probably navigate just about any Inventor problem that we're going to have pretty much this semester. I want to stop for a second and see if anybody has any questions. All right. Anybody have any questions?